Good morning. Recall the laws of logarithms once again. As the first law is log a to the base a is 1. Second law is log a raised to m is equal to m log a. Third law is log a plus log b is equal to log a into b. Fourth one is log a minus log b is equal to log a divided by b. Fifth one is a raised to log x to the base a. A raised to log x to the base a is equal to x. And sixth one is log 1 to the base 10 is 0. So based on these laws, let us solve some problems. Question number 1. Solve log x base 2 plus log x minus 1 base 2 is equal to log 20 base 2. Okay, when you look at this question, the left hand side is log x plus log x minus 1, both have the same base. So here we can apply the law as log a plus log b is log ab with the same base, isn't it? So it becomes log x of x minus 1 to the base 2 is equal to log 20 to the base 2. So here you have to remember both sides we have a logarithm with the same base. So in such case the logarithm can get cancelled. So we get x of x minus 1 is equal to 20, or x square minus x minus 20 is equal to 0. Now when you solve these values, we get x minus 5 multiplied by x minus 4, x plus 4 is equal to 0. That is, x is equal to 5 or minus 4. So here we are getting two values for x. But as it is a logarithmic problem, we cannot conclude the answers by these two values. We have to check the answers, whether these values are relevant for our question, that we need to check. For that, when x is equal to 5, what happens to the left hand side? Let's see. It is log 5 base 2 plus log 5 minus 1 base 2. That is log 5 base 2 plus log 4 base 2, which is same as log a plus log b is log a into b. That is log 5 into 4, 20 base 2. That is RHS. Yes, hence x equal to 5 is a solution. Okay, when x is equal to minus 4, you substitute the values here, like log minus 4 base 2 plus log minus 5 base 2. But here, as per our logarithmic concept, logarithm of a negative number is not defined. Logarithm of a negative number is not defined. As logarithm of a negative number is not defined, we cannot find the value of this logarithm with x equal to minus 4. That means x equal to minus 4 is not a solution, and the solution is x is equal to 5. Next question, solve log x base 2 the whole square minus 8 log x base 2 plus 15 is equal to 0. In this question, you can find out here we have a log x base 2, and here also we have a log x base 2. So if you assume log x base 2 as some other variable, we can make use of complex quadratic equation. So if you assume log x base 2 as a, this equation becomes a square minus 8a plus 15 is equal to 0. Yes. Now you know how to factorize it, how to solve it. It is a minus 3 of a minus 5 equals 0. That implies a is 3 or 5. So that's the value of a. And if a is 3, what's the value of log x? A is 3 stands for log x base 2 is 3, because a is assumed as log x. So it implies, now change it into exponential form. We get x is equal to 2 raised to 3, that is 8. So the first value of x as 8, and if a is equal to 5, we get log x base 2 as 5. It implies x is equal to 2 raised to 5, which is equal to 32. So we get two values for x. Okay, and we have to check the solutions. If x is equal to 8, we get log 8 square base 2 minus 8 log 8 base 2 plus 15 is equal to 0. We need to show that is equal to 0. So that implies log, I'm changing 8 as 2 cubed. Okay, of base 2 minus 8 log, I'm changing 8 as again 2 cubed base 2 plus 15. That implies this is like log a raised to m. So we get 3 log 2 base 2 the whole square minus 8 into, this is 3 log 2 base 2 plus 15. That implies, you know, log 2 base 2 is 1. So we get 3 into 1, 3. 3 square is 9. Minus log 2 base 2 is still 1. So we get minus 8 into 3, 24 plus 15. We just solve, just add and subtract it. We get the result as 0, which is RHS. Okay. This is a similar process you have to do to check x is equal to 32. Okay, if you find x is equal to 32 also gives the same RHS, we can conclude x is equal to 8 and 32 are the solutions. Solve xy is equal to 81 and log y to the base x is equal to 3. It's also a simple question. So we have the first equation as xy is equal to 81, and the second one is log y to the base x is 3. Now what you need to do is just change it into exponential form. You know, in exponential form it will be defined for y is equal to x raised to 3. Remember, a raised to x is equal to n, implies x is equal to log n to the base a. Remember that concept. So what is the value of y? It is x cubed. So this equation becomes x into y. Y is x cubed is equal to 81. It implies x raised to 4 is equal to 81, or x is equal to fourth root of 81, which is fourth root of 3 raised to 4. That makes us the answer 3. Fourth root of 81 is 3. So we get the value of x as 3. Now we need to find the value of y. So when x is equal to 3, y is equal to, we got already y is equal to x cubed, which is 3 cubed. We get y is equal to 27. That means x is equal to 3 and y is equal to 27. Gives us the solution. Solve 4 raised to x is equal to 2 raised to y, and 3 log y base 10 is equal to log x base 10 plus log 2 base 10. Okay, so let's take the first equation. 4 raised to x is equal to 2 raised to y. Actually, we can solve it, we can simplify it by using laws of indices. But here I'll show you how to use the logarithms. Okay, so for that, you see, we can make a small change here. That's nothing but 4 can be written as 2 squared, the whole raised to x. That is equal to 2 raised to y. So we get 2 raised to 2x is equal to 2 raised to y. This is the part of laws of indices. Now, as per laws of indices, it's very simple. Bases are equal. As the bases are equal, we get the idea as 2x is equal to y. 2x is equal to y. If we have a situation to use the logarithm here, what we need to do is we have to apply logarithm on both sides. What should we do? Apply logarithm on both sides. But when you apply logarithm on both sides, there is a question. What should be the base? So in this situation, the base should be same as the base of the questions. Here the base is 2. So let's make the base of the logarithm also 2. So apply logarithm on both sides. We get log 2 raised to 2x to the base 2 is equal to log 2 raised to y to the base 2. That gives us 2x log 2 base 2 is equal to y log 2 base 2. Log 2 base 2 is 1. This log 2 base 2 is also 1. So we get the answer as 2x is equal to y. That is a simplified form of first equation. Okay, so what is first equation? 2x is equal to y. Now let's go for the second equation. In this equation, let us simplify the logarithm here. So here we can make it as log y raised to 3 base 10. 3 log y can be written as log y raised to 3. A raised to m. Log a raised to m is m log a. Which is equal to, it looks like log a plus log b with same base. So we can use logarithm of product, log a into b. So here we get log x into 2, 2x to the base 10. And when you check these two both sides, there is same logarithm. So cancel logarithm from both sides. So we get y cubed is 2x. When you check both these equations, both have same side as 2x. So we can say y cube is 2x, which is y. So we can say y cube is y from these two equations. It implies y square is 1 when you cancel one y from both sides. that is y is square root of 1, that is plus or minus 1. But minus negative 1 is not possible here because y is a number for logarithm. So negative 1 is not applicable. So we get y is equal to 1. Now to find the value of x, we can use any of this. We know 2x is equal to y. That implies 2x is equal to 1 or x is equal to 1 divided by 2 as answer.